Example number 5 now in terms of our rational equations. Here's a function that has x squared on top and bottom. When we factor, that's what we should do first, we're going to end up with this factored equation, and I can see right away, hey, first time that we're going to have a problem where we have something cancel out. So we're going to have a hole in this case. Before I do that, though, one of the main keys when we're doing these problems, you cannot worry about factoring and canceling and anything like that. You must use the domain first, because if you do that and have a domain of negative infinity to positive 2 and 2 to infinity, you've left out this negative 2 of when the denominator equals 0. So we need to make sure that you do your domain before we cancel. So the bottom equals 0 right from the beginning when x equals negative 2 and when x equals positive 2. That's one of the first mistakes people will make. You need to make sure you keep the domain before you cancel. Now we can look at the canceled part. The time when the denominator equaled 0 was at negative 2 and positive 2. That means those can be the holes in the vertical asymptotes. The hole is when x equals negative 2, because this x plus 2 equaling 0 is when you would get x equals negative 2. The vertical asymptote happens for this part, the x minus 2 equals 0, so x equals positive 2. So we're going to have our first case at looking at a hole here in this problem. Our x and y intercepts, we should be able to get those very simply. And here's what's nice. Because we canceled out, we can actually plug in and use just the factored equation. Actually, we must use just this factored and canceled equation, because here's why. With the x-intercept, meaning when the whole function equals 0, meaning when the numerator equals 0, if you use the original equation, well, you would get x equals 1 and negative 2. So you would get 1 comma 0 and negative 2 comma 0. Well, negative 2 can't exist. It's not in our domain. So that negative 2 comma 0 should never happen. If you just use the factored equation here, well, then you have just the x minus 1 part equaling 0, and you have exactly what you need. Remember, negative 8, you should also technically set that equal to 0. Negative 8 never can equal 0, so that guy's not going to be important to us. For the y-intercept, plugging in 0, again, you can use either one for this. If you use this equation, you're going to get 8 on top, negative 4 on the bottom, so you should get a negative 2, so 0 comma negative 2. And if you use the original equation, it should still work out of 16 over negative 8, which is negative 2. So the x-intercept, because something canceled, that's where you have to be very careful because of that canceling. You might get the extra x-intercept, but if you use the factored form for it, you should be fine. Okay, and all that remains is the horizontal and slant asymptote, and here's where, again, you can make your life a lot easier, because instead of using the original equation that has all that extra stuff going on, I can use the factored equation. Your numerator is just negative 8x plus 8. You have to at least expand it back out, and your denominator becomes 2x minus 4. That's going to be a lot easier to divide than this whole big thing. So 2 times what gives you negative 8? That would be negative 4. So you multiply down, you get negative 8x and plus 16. We need to subtract those values. 8 minus 16 gives you negative 8, so your remainder is negative 8. And be careful here with your denominator. Your denominator is what you divided by, so the 2x minus 4. And again, it's a lot easier and absolutely more prudent to do it this way, because you're going to get some extra guys in your remainder if you try to use the original long division. So because of this, though, still negative 4 is our horizontal asymptote. Y equals negative 4. No slant asymptote, and crossing happens when your remainder equals 0. Well, negative 8 never equals 0, so we're never going to cross our horizontal asymptote. So with that in mind, we can now plot everything that we have. So I have intercept points at 1 comma 0 and 0 comma negative 2. Those are the only points that we have. Actually, we're going to have another here point with the hole. We'll talk about that here in 1 second. We have a vertical asymptote at x equaling positive 2. We have a horizontal asymptote at y equals negative 4. So I'll try to draw at y equals negative 4. The only thing left is this hole at x equals negative 2. When we had a cross in our previous examples, we'd have an x and a y value. Right now, we don't know what the y value is. Y equals what? I don't know. So there's actually a way that we can figure this out, and it's actually a very clever and easy way to figure out what the y value is. If we plugged in negative 2 into our original equation, you would have 0 over 0. We can't do that. However, if we use this factored equation, the 0 parts canceled out. If we plug in that negative 2 now, it's going to work. This is actually a calculus idea called a limit. We'll get into a lot of that next year if you have calculus, or if you're in a college class where you'll likely have to take a calculus course. If you plug negative 2 into this equation, you get up top negative 8 times negative 3, and in the denominator, you get 2 times negative 4. So you get 24 on top, negative 8 on the bottom, so it looks like you get a y value of negative 3. So I'm going to plot a point of negative 2, comma, negative 3. Well, I'm not going to plot a point, though, because it's not a point. In fact, it is a hole. So I'm just going to literally plot an open circle. And now I have my graph that I can work with. I've got everything graphed, or everything plotted that I can, and now I connect the dots, leaving that hole at negative 2, comma, negative 3. Now remember, I also have to do something on this side of the asymptote. If I graph above, I'd cross the axis again, so that's no good, so it has to go down below. Now, keep an eye on this too. We already said our domain told you how many pieces of the graph you have. Well, I have 3 parts to a domain. It looks like I only have 2 parts to my graph. 1 part here and 1 part here. Well, that hole actually split that left-hand side into 2 different parts. So really I have 1, 2, 3 pieces to my graph to match my 3 parts of my domain. So there's your introduction to graphing a hole in your graphing of rational expressions.